For this project, we were asked to simulate the response of a vehicle driving over a speed bump. So this is Ben, Aaron, and Kent. We used Kent's truck. It's a 2014 GMC Sierra, so it's a full-size truck. We were able to determine the mass just based on specifications. We were able to find a spring constant by just stepping on the end of the tailgate and seeing how much the spring was compressed. And then a similar way using, we were able to find our dampening coefficient. Then we measured the height, the length of a speed bump right across from south, and we used a velocity of 6.25 meters per second. So we assumed this to be our system. We made the assumption due to tire pressure that there was a negligible spring constant and dampening coefficient in the tires. So that left us with this. Based on some research that we had done and some other calculations we had found, we used a Y value to denote the height of the speed bump based on our distance. To find this, took the derivative of that and found our Y dot. We then plugged that into the equation of motion that we had found and made some manipulations to get to here. Then using Laplace, we were able to transfer that and manipulate it to find our transfer function, which we were able to find this.
All right. So given our transfer function, we used some techniques learned in class and found a zeta, omega n, and omega d in order to manipulate the transfer function. And we came over here and it made it easier to find the inverse Laplace given here. After we did that, we came back and solved for A, B, and C, which is right here.
Taking our general solution to our transfer function, we put it into MATLAB and got our time response plot here. From our equations of motion, if you increase the velocity, the amplitude of our oscillations will therefore increase. So, with that being said, it would be best to drive slowly over the speed bump. However, in this case, with this particular speed bump and vehicle, the velocity had very minor effects on the amplitude of oscillation.